This is going to be part 2 of the FG100 DDS function generator testing. And we're just going to pretty much test the square wave performance, because I had someone actually request that I do this with oscilloscope probes instead of using a direct cable connection and stuff. Even though I did do it properly, he just didn't, I think, see the end of the video or something. But I did do it with actually the internal 50 ohm resistor of the DPO oscilloscope, and I also did it with this term resistor right here too as well. So I did test it actually all 3 ways just to see if it affects performance and stuff like that. And I did that quite intentionally and stuff, and that was going to give it its best shot. Now, he did say though that will draw off the compensation though. No, it actually won't, because if you watch the video, you can see at 1 kilohertz and at 10 kilohertz, the signal, at least as far as square wave, was actually perfect, dead flat. There was no ringing or anything like that. So no, it was not the problem. Because if it was a compensation issue, then you'll notice a lot of ringing and stuff like that. And obviously, it was perfect at 1 and 10. It's just when you start getting at the higher bandwidth at 100 kilohertz and stuff like that, that's when, you know, of course, obviously, it started to drop off. And the reason for that is because this is not a 500 kilohertz signal generator. People probably think it's a 500 kilohertz signal generator. It's not. It's only 250 kilohertz, and I know that because that's where it starts to drop off at the 3 dB mark that we usually test at and stuff like that. So at the full 500 kilohertz, it drops more than half the bandwidth, so it has really bad roll-off and stuff like that. But either way it goes, it actually performed quite well for what it is. You know what I mean? Especially when you consider the first version of this where they were using counterfeit operational amplifiers there. And even at, like, you know, 1 kilohertz or 5 kilohertz, you were noticing a lot. I noticed when watching other people's videos, there was a lot of crosstalk, a lot of jitter, and everything at very low frequencies. And this thing performed way better than my expectation. I actually expected it to perform a lot worse. So I'm not saying it's not a decent function generator, especially for price. It actually is. It's quite decent, and it's quite usable for audio repair work and stuff like that, where you only need slow frequencies pretty much. But right now, you can see there, I'm using a 10x probe, and I'm using, well, popped out, but I do got it perfectly, you know, compensated to it. It's completely flat, no problem with that square wave right there. And here, if you look at the 10x mark right there, you can see it's at 0.2. It's reading about 500 millivolts there, and you can see where I got the sweep setting right there too. So there's nothing wrong with that. Now, the reason why I'm using the analog scope instead of the DPO for this test is because the DPO, I have either active differential probes, and I only have one. Actually, I have about 2 10x probes, but the probes itself don't come with these adapters where I can plug directly into BNC, and I don't want to go ahead and do what everyone else does, which is use this, and it's going to create a lot of noise. It's not going to perform as well, so I want to give this thing its best fair shot that I can. The only leads I have are these Proloma 10x leads, which are actually pretty good test leads themselves. They're good passive probes, but they won't work with my DPO, because my DPO has the settings right there where the when you plug in the probe itself, it detects what probe you're using and stuff like that, and it sets the 10 and 1x, you know, mode depending on where that pin is and stuff like that. So I have to use this one, at least as far as this testing goes, to give it a fair shot. I could do it with the 10x probe, but I would have to use adapters and cables and stuff like that. I want to give it a direct connection, so that's what we're going to do. Okay, so here you go. We're going to plug this directly into there. You can see there it's nice and snug. We got a 1 kilohertz signal. Let's go ahead and put up the sensitivity, because we don't want it too sensitive on this. All right, and then we're going to go ahead and look at a sine wave. And you can see there at 1 kilohertz, that's a perfect sine wave. I'm not noticing any crosstalk, no distortion, anything like that. Of course, if I increase the amplifier, eventually it'll clip, and that's when your distortion will start to come in. When I tested on the DPO, it was around 19 to 20 volts is when I started to notice it clip. And that was, of course, using the high impedance and not the 50 ohm resistor, not loaded pretty much. But there you go. Let's go ahead and just set the position there, right there for now. All right, and then we'll just go ahead and go to square wave there. So we'll go run stop. And this is another thing I noticed too. does the same exact thing there. You can see there's a DC offset like it did on the DPO. And when I turn it on, then obviously I can adjust for that offset a little bit. But yeah, there is a offset, same as testing with the DPO pretty much. Now we're going to go ahead and go to square wave. And we're going to run a square wave on this here. And you can see at 1 kilohertz, it's pretty much a perfect square wave. There's no problem there, alright? So now we're going to go ahead and go to 5 kilohertz. And we'll see what it looks like at 5 kilohertz, alright? And then we'll go ahead and go to a faster sweep setting there. And you can see, perfect square wave pretty much. No problem with that square wave whatsoever. Alright. Now we're go ahead and go to 10 kilohertz. So let's just go this down here. This thing's kind of weird, but it is what it is. Alright. We're going to go 10 kilohertz. We're going to see how well it does there. And we'll go and adjust the intensity there so you can see it better. And you can see there, still pretty clean square wave, quite usable, no problem with that square wave whatsoever at all. Okay, so now let's go, and you know something, we're not gonna bang it into, we'll just do 20 kilohertz and we'll go, you can see there, yeah, that's where it starts, you know, but it's still pretty clean square wave, no problem there. All right, now we're go ahead and do, yeah, I remember I gotta stop this one. All right, we're gonna do 50 kilohertz. All right, we'll go to faster there. Actually, we'll go ahead and turn down the intensity. I'm just doing it for the camera so it doesn't have to be, so you can see it there. Still a reasonable square wave. It's what I would expect from a device that only has 250 kilohertz on bandwidth. All right, and then we're just gonna go ahead and go 70 kilohertz. And yeah, you start seeing there a jitter a little bit, but yeah, not good. All right, it's doing the same exact performance. It's not performing any different than it did when I had the direct coax cable, just FYI. All right, we're going to go 100 kilohertz now. All right, exactly the same as it did on the DPO. And matter of fact, after I do this part, I'm going to go ahead and put the coax cable on the DPO, and I'll show you it's exactly performing exactly the same. There's no difference there. All right, and then we'll go ahead and go 150 kilohertz. We don't want to go and bring it up to 2 because we know it's not going to look good at 2. All right, and yep, and there's your jitter. You can see there. Yeah, but that's at 150 kilohertz and at 2. All right, so let's just go ahead and go to 2. There's one thing I hate, having to stop this thing to do it every single time. Okay. I wonder why I did the jitter at 150, but at 2 it doesn't. But either way it goes, there's your square wave at 200 kilohertz right there, and you can see there it's not really looking much like a square wave anymore. But yeah, it's the same performance. Let's go ahead and just go sine wave here. I know it kind of has that odd behavior too every once in a while. Certain frequencies, I know it's jitter. I know it's with the DPO too. Yeah, but the sine wave performance, very good actually. There's nothing wrong with the sine wave performance there, and didn't even drop off that much, but of course dropped off a little bit. But that's because, let's go to the, what I say is usually the max bandwidth for this thing. Alright, so we'll go 250 kilohertz. Alright, and then we'll run it there. And you can see there, that's when it really starts to roll off a little bit. Not much though, but that's about the max bandwidth there. Because if I go to, let's just say, okay, let's go here. 300 kilohertz. Yeah, I would say right about 3 dB. So it's about 250 to 300 kilohertz. But after that, it's going to drop off way a lot. So if I go one stop, let's just say, not there. That's why I hate that it doesn't keep the same. Okay, we'll go 400 kilohertz. And you can see there, it's below the 3 dB mark. So there you go. But you know, it can be still used to see if you want to see if there's a you know, I mean, you know what? It is what it is. You know what I mean? It still passes a signal. I won't say SIG is not a oscilloscope, but you know, you still get a somewhat usable sine wave at 400 kilohertz. So I'm not gonna say that bad. F5, and you can see there it dropped off way a lot. You know what I mean? It's below half of what it was originally. So that's why I said this is not a 500 kilohertz, you know, signal generator as they claim, because it drops off by about half or a little bit more, at least as the DPO was saying. So there you go, and now I'm gonna go ahead and do the test on the DPO again. So we went back to the DPO, and right now we're gonna go ahead and actually do a 1 kilohertz sine wave. And just to show you, it has pretty much the same issue it was in the analog scope. You can see there's the DC offset when I turn this off, and then when I turn it on I can obviously correct it. And you can see right there I got the position over there, because if I actually have it in the center like it's supposed to be, that signal would be off actually. So there you go. Right now it's centered. That's because I have it, but same thing like on the analog scope. This oscilloscope was recently calibrated about 3 months ago, so it's not the oscilloscope itself, it's a function generator. But we're going to go to square wave, and this is a direct coax cable, by the way, like I had it on the first test. And we're going to go and show you that the square wave is absolutely perfect. And yeah, besides the jitter, as it did also pick up on the analog scope, square wave is perfect. There's no compensation issue or anything like that. So it's not due to that I was not using a oscilloscope probe. And yes, I did also try it with a 1X probe, and it did the exact same thing. So it doesn't matter. Alright, and I even did it with the 50 ohm termination too and all that. But the 50 ohm termination limits, you know, of course, the output that you can put onto the scope, and you have to have it in 1X to do it. So that's the reason why not 10X will actually give it better performance, at least as far as higher frequencies go and stuff like that. So that will actually give you better results than it would if you're using a 1X probe. That's the reason why if you got switchable probes, they put frequency, well, can do up to this frequency at 1X, but at this frequency then you get the full bandwidth on passive probes because of that. But either way it goes, we got direct cable connection, so that's besides the point. Let's just go ahead and go to 5 kilohertz and see how it does on square wave. So we'll do 5 kilohertz, alright? And then we'll go ahead and do the same thing, and you can see there, it does the same exact thing. Now I gotta set the position, of course. Let's not do it too fast there. And there you go, that's center. Now it's actually center, now it's at the higher frequencies and stuff like that. But you can see there, pretty much even at 5 kilohertz, a perfect square wave. No problem with that at all. So we'll turn it off. Pretty much same exact performance. We're just going through it anyway. Okay, we'll just go to 10 kilohertz. Alright, and we'll go to a faster sweep. And you can see right there, it's same thing, starting to have a little bit, but still usable square wave, no problem. But same exact performance with the probe. Alright, now we're going to increase it to 20 kilohertz. Alright, you can see there, still good square wave, still usable. Alright, and then we're just going to go up to 50 kilohertz. Alright, you can see there, that's when it kind of starts, you know, becoming a problem, but still a usable square wave. It's not a problem. Alright, and then we'll go up to 70, same like we did the analog scope. Alright, that's why at 70 you can see the same jitter that you were seeing on the analog scope, because we got this in high res mode. It's able to actually pick it up better than I did with my original test, but same performance pretty much with the probe or with the cable direct. Alright, now we're going to go up to 100 kilohertz, alright? And we're going to do pretty much the same test. Alright, so 100 kilohertz. And you can see there. Yeah. Alright. Okay, and then we're going to go ahead and go 150 kilohertz. We'll go and hit run. And you can see there, the jitter, same exact as the analog scope was picking. It's the same exact performance, pretty much down to the detail. And you can even see it's holding the same, you know, it's reading the same performance pretty much as far as the sensitivity and everything like that. So it's reading right now close to 2 volt peak to peak as it was on the analog scope. So yeah, it's not dropping off and it's doing the same jitter and stuff like that. So there's no difference. Alright, now we're gonna go over to, and let's just go coarse, so we'll go 200 kilohertz. Alright, and you can see there, yeah, not looking as much of a square wave. And like I said, it's because the bandwidth on this thing is not 500 kilohertz. And I'll go and show you. Now we're going to go to 300. Alright, and this one is going to start to drop off. And you can see there, not really looking much like a square wave, and we're getting a lot of jitter. Alright, now we're just going to go to sine wave. See how well the sine wave goes, because now we know that square wave is pretty much a... And you can see there, same exact performance, same exact roll off and everything like that. You know what I mean? We're at the 3 dB and that's what you expect. So like I said, it's about 250 to 300 kilohertz bandwidth is the max bandwidth on this thing. Once you start going higher, and you can even see there, you know, it's a little bit of jitter, but not much. It's still usable as far as putting a signal through, but other than that, let's just go 400 kilohertz. Alright, you can still see a signal there, it's still outputting a signal, but you would have to adjust the amplitude, obviously. But yeah, it's not that bad, you know what I mean? So technically, yeah, I mean, it could do... Hold on, let's turn this off. Let's go 500. This is at 500. And you can see it pretty much dropped by half. You know what I mean? So, yeah, it's clearly not a 500 kilohertz signal generator. It's more like a 250 to 300 kilohertz signal generator. But like I said, its performance, and we'll even go to square wave. Okay, we'll go, actually, you know, so let's just go 500. And you can see the square wave is looking like a messed up triangle wave, but yeah. But you know something, for what it is, still quite a usable function generator, because at lower frequencies, very good actually. It's doing pretty good. You can use this for doing audio work, feeding tones and everything like that. Perfect for that. It's much better than what the first version of this that I've seen people do, where they were using the counterfeit operational amplifiers in there. And pretty much you would get a lot of crosstalk and distortion even at 1 kilohertz and 5 kilohertz and stuff like that. And this thing's performing quite well, so obviously they're using much better operational amplifiers and stuff like that. And it worked out of the box without me having to, you know, reseat the display or anything like that. So, you know, something you did improve on it. Now, I'm not sure it's this version, or maybe you got many different versions where some of them they're using the counterfeit operational amplifiers, or now that they decide to finally go ahead and upgrade them on these newer versions. But either way it goes, I mean, it's a decent function generator for lower frequency stuff, no problem, but it's not 500 kilohertz is my complaint. It's 250 to 300 kilohertz is the max bandwidth on this thing. Now, would I recommend anyone to buy this $19 FG DDS function generator? Yeah, actually I would. For anyone that's looking, you know, pretty much for a slow, low frequency generator for audio work or for feeding a tone and so forth. Quite usable, actually. Quite usable even to feed, you know, clock signals for projects and stuff like that require lower frequency. Yeah, it's perfectly suitable, you know what I mean? I didn't see anything seriously wrong with it, and it performed actually better than I expected it to. Even though I would say it's not 500 kilohertz. The max bandwidth is about 300 kilohertz. I mean, yeah, you get a sine wave at 500 kilohertz and stuff like that, but, you know, rolls off like at the 3 dB market around 300 kilohertz and stuff. If you keep that in mind, I didn't notice any severe distortion or crosstalk or anything like that. And even square wave performance was quite reasonable. So yeah, for 19 bucks, it's a great bang for buck. I mean, there's audio signal generator dedicated ones, the portable ones that cost 50 to 80 bucks, and those only do the audio frequencies. So yeah, it's quite a good bang for buck, just so long as you get one that actually works similar performance like this one, where you're not getting one to counterfeit, operational amplifiers are ones where the LCD comes loose because they only use one screw to hold it down, and the standoff that's way too big. But other than that, if you get a good one, it's a great piece of kit to have around, and you can power it off your power bank and stuff like that and use it on the go as well. So the nice thing about it works as an isolator because you can run it off batteries. So yeah, I do recommend it for 19 bucks, and I think it's a good bang for buck pretty much.